Hey guys, welcome back to the channel. Today we will go through the beautiful family of numbers. Many students and children who's not interested in mathematics think that numbers are just lifeless symbols on paper. But I'm telling you that numbers are not just cold, lifeless symbol on paper. They are a family with personalities and secrets. So today let's meet them. So first the type of number is we will discuss about the natural number. ठीक है. So the natural number is the counting ones that we are regularly count 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. So these are the natural numbers. The first one is our natural number. Natural numbers are represented by n symbol. Okay, and we can call them that the counting ones, which mean, for example, like 1, 2, 3, 4, so on. Okay, so they are the ones we first meet as a children when counting toys, apples, and days until the weekend. They are positive and they never stop climbing like a staircase. Okay, this is the first type of the numbers, that is a natural number. And the second one comes with that whole number. The second is whole number. Whole number is represented by a W, and we can say this is a calm one, because that one day their quiet cousin zero joins in. Okay, so together they make the whole numbers, some as the naturals with the calm balanced zero leading in the line. If we add zero in the front of that natural numbers, we will get a whole number, which means 0, 1, 2, 3, 4, and so on. So this is a whole number series if we are getting added by 0. Okay, now the third one is integers. Integers, we can say, let's go with the depth in the family. So integers is represented by Z, and we can say that the family of depth, family with depth. Okay, so we can say we can see in the life that life isn't all positive. They are negative, some things are negative, some things are positive. So similarly, like in numbers, we have some positive numbers and we have some negative numbers also. So the integers know that the negative number and the positive number, the whole number is called integers. Okay, which means if we include the negative side of the numbers, for every positive they are matching negative also. Okay, for which mean, let's suppose if we have a 0, 1, 2, 3, dash dash dash, so on. So the negative side also -1, -2, -3, so on. Okay, these are called integers. The negative 0 positive integers and the negative integers. Okay, next is the rational number. The fourth one is rational number. Rational numbers are we can say represented by Q. Okay, so if we are going with the rational numbers, we can see in the integers we can see whole numbers like 0, 1, 2, 3, and 4, 5, like this. But what about the half, quarters, rational point, decimals, numbers. Okay, so these are the rational numbers that which numbers can be expressed into a fractions and the decimals, that they can be write as a rational number. Okay, for example, or we can say, if a number which satisfy p by q statement, where p and q belongs to are integers and q should not be equal to 0. Let me write it, that q should be follow p by q, where p and q belongs to, that this symbols belongs to z. Z is integer and q should not be equal to 0. So let's suppose if for example 9.25, 0.75, 1 by 4, 1 by 7, these kind of numbers are the rational numbers. Okay, let's go forward for irrational numbers. The fifth one is irrational number. Irrational numbers are some wild majestic number, I can say mystic number. So not all the numbers can be termed by fractions. Okay, that we cannot express all the numbers in fraction. Let's suppose root 2, we cannot express as a fraction that is satisfied by the p by q, that we cannot express this in this form. Okay, so meet the irrationals, like for best example is pi. Okay, root 2, root 3, root 5, root 6, root 7, these are called irrational numbers. Okay, irrational numbers are the numbers, they will go with the decimal with forever without repeating. Okay, let's suppose like for just for example of a pi, that 3.14 something goes on without any repeating number. Okay, so they are mysterious, beautiful and infinite in complexity. Okay, the next number is our sixth number is, that is real numbers. Okay, represented by r, and here the real number is the combination of rational number, rational per plus irrational. Okay, it means real numbers put all the rational and irrational together and you will get the real numbers to complete number line. Okay, they are the stage where all these characters play. Okay, the rational and irrational, that it will satisfy some p by q statements also, and that some root 2 pi and root 3 repeating, not repeating numbers also. And the last one is, seventh one is our imaginary number. Imaginary number, or we can say complex number, I call the dreamers. Okay, so the imaginary number is, let's suppose some of the numbers that we cannot represent, like minus root 1 or minus root 2. How we can represent them? They doesn't exist. Okay, so in mathematics, imaginary numbers are expressed as a iota, that is called I. It's called iota. That is the reference for the imaginary numbers. But beyond the number line, some numbers lies in the imaginary world, number that involve the square root of minus 1, which is denoted by I. So in the imaginary world, but -1 will be denoted by iota, that is I. Okay, combine the real with these dreamers, you will get the complex numbers. With the real me, the way the math becomes truly magical. Let's suppose we can combine the real numbers with the imaginary numbers. Let's suppose 2 plus iota root 3, like this, where the 2 is the real number and root 3 is imaginary. Okay, we can create a different kind of uh, universe or something we can call. Okay, so numbers are more than symbols, they are infinite in family, each with their own story. Okay, learn them and don't just do maths, you can speak the language of the universe also. Okay, so stay curious, we'll meet in the next lesson. Thank you.